You kind of jump around.
Oh, well, I don't like this. What? Sheldon, you're evil. You need a reminder. What? Track is on the iPod.
Okay, you guys ready?
Yes.
Okay. So when we multiply, what's our first step? Or when we do anything, usually what's our first step?
Common denominator.
Already we get magic numbers.
Yeah, we can factor, right?
Oh. What do you mean?
So if we look at this denominator, 3x plus 21, what can I factor out? A 3? So I haven't done anything with my numerator. And I can factor out a 3. If I factor out a 3, what do I get? Yeah, x plus 7.
Wait, what?
We took out a 3 of this
We have
bottom.
to do that?
Yeah. Okay. We're on the top and the bottom. So then I'll have x plus 7 on the top. What do I have on the bottom if I take out a 4?
X minus 6.
X minus 6. Okay, before we simplify and cross cancel and everything, what can I exclude?
Negative 7 and positive 6.
Yeah, I can exclude a negative 7 and a positive 6. Yeah, now I can simplify. So I have an x plus 7 in the bottom and an x plus 7 in the top.
And then it's 6 minus x. And the 4 makes a little 1.
Yeah, I can simplify the 4s too. So what am I left with?
1 over 3.
Wait, how do you wait? But you are simplifying crossing and then you simplified up and down.
With multiplication, we can do that because it's all technically one big fraction.
You're just simplifying with whatever you want?
Not quite. Here, I'll rewrite it
What?
this way.
How do you multiply fractions? Straight across, right? So you can just extend the fraction variable.
Oh.
So it's one big fraction, right? So I can go the 4s, the x minus 6.
Oh, okay.
Okay. So then, yeah, we're left with 1 over 3. Okay. How are we feeling with multiplication?
Where did it come from?
With what?
Where'd the 1 come from?
Because we need something on the top. Yeah, everything cancels on the top, so we need something up there.
Yay. Wait, and if it was the other way around, if it was 3 and 1, could we just put 3?
Yeah. Okay. What do we do with division?
Well, you still factor them too.
Yeah, we got to factor first. How does the top factor?
Different squares.
Difference of squares. What would my factors be?
Y minus 4. Y minus 4. Y minus plus 4. Well, y plus 4.
Y minus 4, y plus 4.
Didn't you just put y and then in parentheses y minus 4? Why not?
Because we need the, if this had a y, then we could pull out a y. But they don't both have y's. Okay.
Whoa, what? I don't like this one.
Can I do anything on the bottom?
Wait, what?
There's nothing to factor out right there, so I just bring it down. So we leave the y plus 4. What about the bottom?
5 minus, 5 y minus 4.
Okay.
No, yeah. I just like it.
Exclude a positive 4. Okay, I like it.
Wait, what?
We're just finding the 0 of the bottom.
Yeah, flip it.
Keep it, change it, flip it.
Cross things?
With division, no. We have to flip it and then we can cross. So we have y minus 4, y plus 4 over y minus 4.
Yes.
What does division turn to? Multiplication. Okay. And then what does that fraction become?
5 times y minus 4 over y plus 4.
Yeah, how do you do it?
Because we can't divide by a fraction, but we can multiply by its reciprocal.
Wait,
You can
now,
exclude that negative 4 also.
Yep, then we have to look. We have a new number that we have to add.
what?
So do we just keep it, change it, flip it, that second factor?
Mhm.
Okay, okay.
But what happens with the top?
We flipped it.
But it's still there. Just disappeared in the answer?
Which top? What do you mean?
Both tops?
Well, this one stayed the same, right? We just dropped it down.
But you didn't put it in the answer.
Oh, with those over here, we're only looking at our denominators.
Oh, it doesn't matter what's up.
Right, because how often can you divide by zero?
Well, it's, yeah, I guess.
See what I'm saying? You could, zero on the top is fine, you just can't divide by it.
Okay. So you just ignore it?
For finding the excluded values, yes.
Oh, okay. Can you put the opposite or you put the same?
Opposite. We want the 0 of the bottom. Okay.
Okay.
Okay, so now that I have multiplication, what can I do?
Cross cancel.
What can I cancel?
0, y minus 4, y plus 4.
Okay, so we got y minus 4, y minus 4, y plus 4, y plus 4. What do I have left?
5
Times
times
y minus 4 over 1.
Yeah. Do I have to write the 1?
No, you did. I did.
So we get 5 times y minus 4. Okay.
You get it out.
No.
Oops, sorry. Okay. What's the LCD of this one?
What's it? What this LCD?
Least common denominator. X is one factor. What's the other factor? Yep. So the LCD is x minus 6. A timer.
I thought it was like gonna explode or something.
Okay, how we feel about finding the LCD? Yeah, it's all the factors that you see in the bottom.
And now what?
We're just waiting for them to write it down.
Oh.
We were? We good? Okay. Now what are we doing? Well, let's see. Are those bottoms the same?
Yes.
Yes, so what do I do?
You,
Wait, how did you get that?
This is a new problem.
Oh.
just let that make it 1.
Yeah, we can make it one fraction because I have this numerator, x squared plus 6x. And then what?
Like disappear?
The what?
If the bottoms are the same, can you just like disappear them?
It'll become one fraction. I'm just writing the top right now. Okay, so what operation am I doing? Subtraction. And we'll want to put parentheses here to tell us to distribute that negative to both terms.
Wait, what? To distribute what?
The negative.
Oh.
What's on the bottom real quick? You can factor it if you want.
Oh.
X plus
8 times plus 8.
X plus 1.
X plus 8, x plus 1. Okay, before we do anything else, what values do I have to exclude?
A negative 8 and a negative 1.
Okay, what can I do next?
You can factor the x out of the x squared plus 6x.
Well, can I combine like terms up top?
Yeah. You get 6x plus 6.
Yep, these x squareds will cancel. So we have 6x. A negative and a negative becomes a. So you get 6x plus 6 over x plus 8 times x plus 1. How can I factor the top?
Oh, oh.
So if I take out 6 out, I have, okay,
Oh, okay.
bottom stays the same. What do you notice about top and bottom? So what's the final answer then?
6 over x plus 8.
Yep.
Well,
Any questions? Yeah?
Lakewood Park?
You're good?
You can't park that.
Okay. Do you want to try one on the boards?
Yeah.
Okay, go for it.
Yeah. You gotta actually like.
Over x plus 4, x minus 7.
Okay, what was it? You multiplied these?
Yeah.
Yep.
So we have 5.
X plus 20
Okay.
over x plus
Do you want to write two different fractions or do you want to make them one fraction? 2? Okay, what's my denominator?
x plus 4, x minus 7.
Okay.
Plus 3x minus 21.
What's my denominator?
X plus 4, x minus 7.
Yeah, x minus 7.
You combine. 8x over negative plus 4. 8x minus 1.
Plus 4 should
Over 4, x plus 4, x.
Okay, combine numerators. Get 8x minus 1. Denominator stays the same. Can I do anything else? No. So that's the final answer.
Not bad.
Okay. What is this asking us to do? Simplify what?
Complex rational expression.
And what's a complex rational expression or fraction?
X over 7 inside a fraction.
Yeah, so it's
Inside a fraction.
yeah, fraction inside of a fraction pretty much. Do you remember what we have to do before we can think about dividing it?
Get the denominator?
You have to get the fraction out of the.
Yeah, our denominator is fine.
No, like, get the top, have the same.
Yeah, we want this to be one fraction. So what would the denominator up top be? 7. So how could I change 1 to have a denominator of 7?
Times this. Probably times by 1 over 7. Well,
Not 1 over 7.
You times the fraction, so you cancel out the x times the 7 over 1.
Not 7 over 1.
-7.
So we're not doing anything to that first fraction. That's staying the same. We're changing the 1 so it has a denominator of 7, right? So 7's in the bottom. What has to be on top to give us 1? 7, right? Anything divided by itself is just 1. You technically, there's like an invisible 1, so we can multiply top and bottom by 7 to get 7 over 7.
Like that.
Yeah.
Over x minus 7.
Over x minus 7, okay. There's also a little 1 down there. That'll be helpful to us. Okay, what do I do next?
You combine
Combine what?
the x minus 7.
We can combine this into one fraction
X minus 7.
because now I can use keep it, change it, flip it, because I have a fraction on top and a fraction on the bottom. So that'll help us to say that it's 1 over x minus 7. If I'm flipping this and it's just this,
Oh, okay.
So you just flip it to make it a multiplication instead of a division?
Right, I understand that. So it's just 7.
it's not just 7.
It's 1 over 7.
It's 1/7.
It is 1/7. Because these will cancel.
Because x can't
We have to find the excluded value. So this is our denominator. So it's positive 7.
So it's.
Are there any questions with this one? Nope. Okay. What am I doing first?
Please question.
Do you put it all at the same side?
Could you square root the right side?
What do you mean right side?
Like, could you square root 18? Oh, wait, no, not.
18 is not a perfect square, but we can do something with the bottom.
Square root x squared.
Magic number.
Difference of squares. So that one stays the same. What would it factor into if I use difference of squares?
X minus 1, X plus 1.
X minus 1, X plus 1. You can do the addition first, too, if you want. Okay. What can I do when I have a fraction equal to a fraction?
Oh, you have a fraction equal to another fraction.
Wouldn't the bottom cancel, like x minus, cancel the x minus 1?
Equal them to 0.
Multiply X plus 1.
You could go back.
Multiply what by x plus 1?
The bottom of the other fraction.
You want to get common denominators?
Nah, it's kind of like an idea.
It is. There's a little simpler one. What if I did this?
Oh, cross multiply.
Yeah, cross multiply.
You can do that.
We can do that because they're equal to each other.
Oh,
So I have 18 times x minus 1 equals what?
18x minus 9 times x minus 1 times x plus 1.
Yeah. So after I get there, what can I do? You said it before.
Distribute
Distribute, right? What would I get over here?
18x minus 1.
Okay. And what about over here? What's going to happen?
Would it,
Would it just be X?
wouldn't it just equal itself to
9x minus 9?
Well, we said that this was this, right?
Yeah.
So could we just multiply 9 by that?
Yeah.
So what would I get?
9x squared minus 9.
And then you could take out
I could take out a 9.
an 18,
Well,
or not really.
if I take out a 9, I'm just going to backtrack everything I did here. But are all the numbers divisible by 9?
You all add it to one side or no?
Yeah, we can add it to one side before we do something.
They're all divisible by 3.
3.
They're also all divisible by 9.
Divided all by
Fine, so
9.
you can take out, I thought you said you could take out 9.
It's alright. Divided
Swear.
all by 9.
I was thinking like from here to up there,
Oh, okay.
like factor it out. But we can divide by a 9.
So, 2x minus 2 equals 1.
Equals x squared minus.
Okay, what do I do?
You could take out 2.
No, I don't want to do that.
Get it all on one side.
Do I want to move it this way or do I want to move it that way?
The right side.
That way.
So x squared is 5.
So we got x squared. If I'm subtracting 2x,
Minus 2x.
plus 1. How do I factor that?
X plus, oh no, x minus 1.
Magic.
X minus 1, x minus 1. So what is my solution?
1.
Yes, just 1. So there's one step that we didn't do beforehand, is find those excluded values.
Negative 1 and positive.
-1 and +1. So if those are excluded values, what happens with our solution?
Wrong.
Yeah, it's not valid anymore. So in this case, there is no solution.
There was a purpose, you know what it was.
Okay, if I have two fractions equal to each other, what process do I use?
Cross multiply.
Cross multiply. That'll save you some work. Any questions with this one? Do I have a fraction equal to a fraction? Nope. So then I use the other method, which was the LCD. What would my LCD be? Yeah, we have two different factors, x and x squared, which gives us x cubed. Okay? Do you remember what we do with that x cubed?
Somewhere. I don't remember. Go to shop? Yeah. No. Make it X.
Well, we'll multiply everything by that LCD to cancel fractions. So what's 1 times x cubed? Okay. And then what's 3 times x cubed? 3x cubed. And that's still over x. And then what about 18 times x cubed? And that's over x squared. Okay. How can I simplify those? This one can't do anything too. But what about here?
Take out X.
Yeah. Yeah, I can take out an x, so I have 3x squared. 18x over there.
Yeah.
So what would I get if I move the 18x over?
6 Yes. X plus 6. Oh, wait.
Not 6.
3.
Yep, 3.
Minus 18x.
I forgot to say that.
Okay. Yeah, I can take out an x. If I take out an x, what happens?
You get x
Squared plus 3x minus 18.
Okay. Can I factor that quadratic?
Yeah. X plus 6. X minus 3.
So I get x times x plus 6, x minus 3. So what are my 3 solutions then? Yep, we get 0 here, -6, +3. So we didn't do it before, but what value do I have to exclude out of my denominator?
Because we took out what, x cubed? And we did 0.
Do we just have x's in the bottom?
Yeah.
Nothing being added or subtracted down there?
Yeah.
So what value do we have to plug in to get a 0? Just a 0, right? That's a terrible 0. There we go. So what does that mean for our solutions?
They all work? Oh, wait, one of them doesn't work.
Which one doesn't work?
The 0.
So in this case, -6, +3 are our solutions. Questions? Do you need more time to write it down?
Yes.
Okay.
Well,
We all good?
it does.
This is the same as the last one, just a little different.
All right.
Do you want to do it on the boards? If you don't mess around, I can let you do it on the boards. Boards? Okay.
Now, take a second, think about this one before you jump in. What do we do if we're solving an equation like this that has a bunch of rational expressions, a bunch of fractions? We got to find the LCD. Good. Now, take a second. Think about all the kinds of problems we've dealt with. What have we really done? We've added and subtracted rational expressions like this. We've multiplied and divided, and we've solved equations primarily, right? That's the main stuff. In which of those cases did we need to find an LCD? Ones like this, right? When we're solving an equation, we'll get back to this one. What other ones did we need to find an LCD for? Okay, when we're adding or subtracting fractions, we needed to get a common denominator, right? And we needed to find the LCD for that. Did we really need to find an LCD when we're just multiplying fractions? No, that's the easiest thing to do, right? You just multiply straight across, really just extend the division bar, factor everything, and cancel like factors, and you're done. Dividing is almost that easy. You have to factor and then flip and multiply, right? But again, you don't have to really find any LCDs in those cases. But we need to here. So to find that, we got to factor everything, right? Okay? So not the tops, just the bottoms, right? We got to factor all the denominators. So that one's done, that one's done, that one's not. So what do we need to do here? We got to find magic numbers. Good. So we've got 4 over x minus 2 minus, I'm going to give myself a little more room here. I wasn't really thinking ahead. Minus 2 over x squared minus x minus 2. Whoops, no it's not. Oh my goodness. Kind of out of practice, aren't I? Two over x plus 1 equals negative 5 over what? What does the bottom factor into? Okay, good. Magic numbers need to multiply to negative 2 and add to negative 1. Let's play the sign game real quick. It's been a while, but this is good stuff to remember. What are the signs going to be if my magic numbers multiply to a negative and add to a negative? Negative and a positive. Good. Okay, and it's negative 2 and positive 1, you told me. Okay, so what's my LCD then?
X minus 2, x plus 1.
Everybody agree? And again, what's the LCD? The LCD is just the product of all the different factors that show up in denominators. That's it. Well, what do we have? We just have x minus 2s and x plus 1s. So that's my LCD. Now, what do we do with that? What are we doing with that? Okay, we just want to clear fractions, right? This is the same thing we did, man, about like 8 months ago, right? When we did problems like this. Like, what would you have done if I had said something like x over 2 minus 1/3 equals 2/5? What would we have done?
Get them to have the same denominator.
Well, I mean, we could, but that's a lot of extra work. We were just going to clear fractions. What number did we want to distribute through to clear all the fractions? What did we do? I mean, it's been a while, but we did this a long time ago. You did this many times. What number would you have multiplied through to clear all those fractions? What do you think? How would you find it? What are we trying to find here? The smallest number that what? Okay, that all these would divide into evenly. What's the smallest number that 2 and 3 and 5 divide into evenly? That they divide into evenly. What do you think? Come on now. I mean, what if it was just those two? What would you do? Multiply by 6, right? Because 2 and 3 both go into 6. But now I've got another denominator, so what would I have to do? 30, yeah. I just take the product of all three of those, right? 2 times 3 is 6, times 5 is 30. So I would multiply through by 30. Well, guess what? What do you think 30 is? 30 is the LCD of all the denominators, right? So we've done this. We've done this many times. We would have just multiplied through the whole thing by 30. And what would have happened? 30 over 2 would have canceled to what? 15, right? So we would have just gotten 15x minus 30 over 3 would have canceled to 10. So we would have gotten minus 10 times 1. 30 over 5 would have canceled to 6 times 2. Would have given us 12, right? And we got an easy equation to solve then. Remember this stuff? That's all we're doing now. Same thing we're doing now. We're just going to multiply through by the LCD and look what's going to happen. If I distribute that through the whole thing, well, look what happens. I get 4 times x minus 2 times x plus 1 is what my first fraction becomes. I'm going to do this in 2 steps. Come on. There we go. So we're just going to distribute through the entire thing. X minus 2 times x plus 1. When I distribute there, what do we get? We're just multiplying that times the numerator, right? So I just get 4 times x minus 2 times x plus 1 over x minus 2. What happens? Yeah, there you go. So we canceled the x minus 2 factor minus 2 times x minus 2 times x plus 1 over x plus 1. What happens? Okay. Equals negative 5 times x minus 2 times x plus 1 over x minus 2 times x plus 1. What cancels? Everything. Yeah, both those factors cancel, don't they? Okay, so what's that leave us with then? When all the dust settles, so I get 4 times x plus 1 minus 2 times, x minus 2 equals negative 5, right? Now, what would I do to finish solving this? Distribute, collect like terms, and then this is easy, right, from here on out. So if I distribute the 4, what's that give me? If I distribute the negative 2, what's that give me? Good, minus 2x plus 4 equals negative 5. So if I add like terms, what is that? 2x plus 8 equals negative 5. So what would I do to solve for x here? Subtract 8 and then divide by 2. And we got it. Good. So we subtract 8 from both sides. Those guys cancel. I get 2x equals negative 13. You told me to divide by 2. So we got it. X equals negative 13 halves. Good? Okay. Give me 1 to 5 on that. How are we doing? Okay. We're getting there. All right. Okay, probably just need a little more practice. That's all right. We'll get you. I want to get done with this so you can finish getting your practice in. Okay, what about these variation ones? So if y varies directly as x, what did that mean?
Y equals k times x.
Okay, good. If it varies directly, remember what that meant. That meant that y equals k times x, right? So that's my direct variation equation. We just need to figure out what k is. How do I do that?
Plug in 8 for y, 56 for x.
There you go. So we know some values. I just have to plug those in. So I get 8 equals k times 56, right? So how would I solve for k?
Divide by 56.
Divide by 56. So those guys cancel. So k equals 8 over 56. What does that reduce to?
1/7.
There you go. I could divide each of those by 8, couldn't I? So I get 1/7. And then what's my variation equation?
That's all for
Y equals 1/7.
There you go. Yeah, now I know what k is, so I just plug in that value for k, and I've got it. Y equals 1/7 times x. And that would work for any, I could use that equation and plug in a value of x, any value of x I want, and find the corresponding value of y, right? Okay, give me 1 to 5 on that. How we doing? Okay, all right, all right. Okay, last one. Now this is different. Y varies inversely. What in the heck does that mean?
Y equals K over X.
Okay, y equals k divided by x. Directly means it's k times x. Inversely means it's k divided by x. Okay, so y equals k divided by x. They gave us, again, we know some values, right, of x and y. So what's that tell us? That tells us that 8 equals k divided by 7. What would I have to do to solve for k? Multiply by 7. Good. And I want to do that so I could cancel those guys. And then k equals 7 times 8. What's that? There you go. Okay. So k equals 56. Now be careful with this. What's the inverse variation equation going to be? Y equals, okay, good. K, which is 56, divided by x. There you go. That's it. Okay? Good? All right, go to work. When's the test? Tomorrow. Okay.